Hello, ladies and gentlemen. This is Fath Rahman Kamal from Mechatronics Engineering School at UNIN. Today, I would like to welcome you for today's presentation for the performance of extreme learning machine classifier. This presentation is going to be go through this content. So, starting from introduction, going to the results, ending with the results. So, first of all, in the field of machine learning, classification plays a critical role in various application, which it's involve the categories data into the preferred classes or the groups based on the features. So the accurate and the efficient classification algorithm are essential of the task, such as the image regression, sometimes for the spam filtering, and many others. So today we will explore the concept of ELM classifier and the significance in machine learning. So first, so here it is an important question. So what is the classification? So before we delve into the ELM, let's briefly discuss the fundamental concept of the classification in machine learning. So classification is the process of the assigning labels or categories to the data based on their characteristic and or maybe attributed. So ELM classifier, also known as the extreme learning machine, is the powerful algorithm design or for the classification tasks. So we can give here an overview on the ELM classifier. ELM classifier is the popular machine learning algorithm using for the classification tasks. So also, ELM has the gained attentions due to the first learning speed, so which means it's fast and also have the good performance as well. So also it has been successfully applied in various domains, including pattern recognition, image classification, and the natural language processing. So here we go to the how the ELM classifier working, how it's working, how it's designed. So ELM classifier actually is operates based on the forward neural network architecture. So it's going to one side. It's no feedback, just one side. So the network consists of the input layer. So input layer here, hidden layer, and then we have output layer. This can't be like two layers, should be like one layer as the one hidden layer. Maybe it's going to be a different number of neural network, but this is the famous design. So in ELM, actually, the hidden layer neurons are the randomly initializing and remain the fixed throughout the training process. So during the training, actually, I mean the training test, in the input data, it feeds through the network and the output layer waits updates every time it's updated. So the ALM achieved the fast learning and demonstrates good generalization performance. So after we know and see the design of the ALM classifier and how it's work, so we can go to the advantage of the ELM classifier. ELM classifier actually is offers several advantages. So first is its fast learning speed, allowing to process a large data efficiently as well. Though, so the second point we can go actually, which is the ELM classifier has the simple implementation with the fewer hyperparameters So the term marketing is easier to use and deploy as well. Let's take us to the third point, which the ELM demonstrates good generalization capabilities, reducing the risk of the overfitting training data. So going to the last point, which the ELM is capable and can handle the high demonstrate data with easy. So it's not that difficult to him. Oh, sorry for the ELM classifier. So here we can make like the fast conversion um, between ELM classifier as the single classifier with the KNN classifier, which is the key nearest neighbors classifier. So let's compare between the ELM and the other proper classifier. The KNN, it's worked by assigning a class label to the new data point based on the majority votes of its the k nearest neighbors. That's the first one. So why the both of ELM and the KNN are used for the classification, both of them is using classification. They have a different working principle. So the way they're working, it's not the same. As also the advantage of the ELM is more, it's better than the KNN. It's faster. ELM is faster, so the ELM is outperformed KNN in terms of learning speed and its capability due to its the analyzing weight computation. So, however, the choice between the ELM and the KNN depending on the requirements of the problem we have. So, so here to access to the performance of ELM and KNN, so we conduct the experiments on multiple data sets. So we used Iris and this list of data sets here with varying so different the number of instances and the number of features. Also the class, only the thing is the common thing between all these 5 data sets. And all these data sets, it's real data set. So going to the results of to make the views clear to everyone here. So starting with split the training and the test data. So separate the data test to training test and the sorry test set and training set as well. So here we was trying to find which is the best splitting ratio. So we starting for the first data set, which is the iris one, with 70-30, is 80-20, it's 9-10. This is show the number of the training test, and this is the test set. So we get the results of, well, we're gonna take the iris as the example to explain. So starting with the first ratio, which is 70-30, we get the result. The accuracy result was 95.2%, which is the KNN is better on this point. So after the make the another set and the training set as well. So here the ELM is starting to improve to be the same value of the KNN accuracy as well. So going here at this point, also the KNN on the iris is better than the ELM. So we can go through all this data on the same concept. You can see here I think graphically we can see here. So you can see that the efficiency of ELM actually is depending also on the number of neural network in the hidden layer. As we said, as everybody know, it's we have like input layer and then hidden layer and then the output layer. So in the hidden layer we need to set how many number of neurons should be in this hidden layer. So we did also the experiment of iris here, and this x-axis show us the number of hidden neuron, how many of them, and then here for the y-axis we can see the accuracy as well. So to explain here, so starting also the training set show the green line and the test set show the red line. So as we can see here, the training set and the test set is going up on the same um, ratio of learning until some point here when the test set starting to keep under the training set. So the model is just keep training high going up, increasing, and then it's just be like it's not changing. And in some point here, so it's almost 59 number of neurons. So we can see the training set and the test set is starting to going down. Why? Because very high number of neuron of the hidden neuron in the hidden network in the hidden layer can be decrease the accuracy of the training set and the testing set. So here we just make the range which is the best result that we can get, which is when starting the neural network from 1 ending ending for 25. So we did the same thing for all the classifiers that we did. I just showed the iris and the second classifier here. So this is the same. You can see here, oh, here is like starting from 0.9, also it's almost 0.9 for both of training set and test set. And then the models keep training and the accuracy of the training is going up, and then at some point as well it's drop as well here. So that is the range. We can say it's the best number of hidden neurons in here. At the calculation of this presentation, we need to make it fast because I just have 2 minutes. So here can see how calculate the changing of the dataset splitting the percentage, which means the dataset and the trend set, it can be affect the classification accuracy, as we can see, as we saw in table 2 and the graphs as well. So also we have compared the ELM and the KNN classifiers regarding the classification accuracy on the iris dataset and also for 4 more datasets. So we saw in all datasets that not all of them, the ELM outperforms the KNN in classification accuracy, as it's already clear in table 2. So one more important thing, which increasing the ELM hidden layer nodes improve the accuracy, but the KNN performance didn't significantly improve, which means increasing the hidden layer nodes improve the accuracy on ELM. But one more important thing here, as we saw in the graph, is very high in number of nodes in the hidden layer. It can be like decreasing in the value the accuracy of the training set and the testing set as well. Oh, I mean testing accuracy and the train accuracy. Sorry for that. So it's almost 5:15, so thank you everyone.